In this video, we'll find some Fourier transforms by looking at using some of the properties we've seen. And in this case, we actually will know the Fourier transform of the signal is going to be 5 over 2 plus j 2 pi f. Perhaps you recognize what the signal must be is a decaying exponential. But what we're interested in is if now the signal is f3t, I'm sorry, s3t minus 2, what is the Fourier transform of that? And another one we might be interested in is now what is the Fourier transform of the derivative of the signal? And again, we can use our properties, so we don't actually need to solve the Fourier transform. For this first one, we will rewrite that as 3t minus 3 halves. And we have two properties that we need to use. One is the scaling property, where we have a scaling factor of 3, and then the time shift property, where we have a time shift of 3 halves. And so if we take the Fourier transform, we can look at our table, and we have 1 over the absolute value of 3, and then s of f over 3 is how we deal with the scaling. And the time shift introduces this phase shift, e to the minus j 2 pi f times 3 halves. And so, oh, I'm sorry, I did the math wrong. That's 2/3, so that's 2/3. Perfect. Okay, so we can go to our original signal here. Now we have 5/3, right? So 5 over 3, and then we have wherever we find this f, we have to put f over 3, so we end up with 2 plus j 2 pi f over 3 e to the minus j 2 pi f times 2/3. And we can clean that up a little bit if we want, multiply 3 by 3. For the other one, when we take the derivative, we just multiply by j 2 pi f. So this is just going to be j 2 pi f times s of f, which we already know. So in this case, we have 5 times j 2 pi f over 2 plus j 2 pi f. Not too bad using the tables.